Question 13 is asking you to kind of look at some patterns. This really leads into some things that we'll do when we start talking about something called trig identities, and actually leads into something that you'll look at when you're in pre-cal. So really kind of laying the groundwork, probably more of a challenge problem at this point, but still some things that I want you to be thinking about long term. There are some relationships between trig values in different quadrants for angles that are in similar positions. So they give you an angle theta here, and they're asking you things, and I'm not following the example questions, I'm just doing kind of the same sort of thing. They're asking you to define things like cosine of theta, and it's going to be in terms of A and B. So, just act like you have points there and just use those in place of the points. We're on a unit circle. So for example, if they ask you to find cosine of theta, cosine is just the x-coordinate. So the x-coordinate here would be A, and that's all you have to do. If you really want to, you've got a triangle here. They're saying it's on the unit circle, so they're telling you that's 1, that's A, and that's B, if you want to use your old right triangle rules and do it that way. Just keep in mind, if you've got an A going back this way, it's going to be negative. If you've got a B going down this way, it's going to be negative. So do watch your positive and negative signs, okay? One of the things that they're doing here is they're doing things like asking you for sine of pi minus theta, okay? Remember, pi radians is the same thing as 180 degrees, okay? And they're asking you to subtract that angle, okay? So this is a little bit abstract, trying to imagine, what does that look like? You might want to imagine that this is like a 40-degree angle. Where would 180 degrees minus 40 be? Well, that would be 180 degrees, and you'd rotate up 40. All this is you're going out to 180 degrees, and you're rotating back theta units. And so what it's going to do is, again, my picture's not great here, but it's going to give you basically an angle that ends over here. It's going to be symmetric to this angle over here. So if you're going over A and up B here, you're going to go back A and up B here. And that's going to be the coordinate negative A comma positive B, okay? So again, there's a lot of symmetry in these problems, but signs of A's and B's might change. And so anyway, the sine is the x-coordinate. Oops, sorry, sine is the y-coordinate, so the sine is going to be equal to B. Cosine would be the x-coordinate, it would be negative A, okay? So anyway, the point here is when you rotate into another quadrant, maybe the sine changes, maybe the cosine changes, maybe the value stays the same, maybe it doesn't. Different relationships for different trig functions, and something we'll continue to build on a little bit. If I ask you something like sine of negative theta, okay, where would negative theta be? Well, you would rotate down, you would go clockwise instead for a negative theta angle, okay? And once again, that's going to be symmetric to this point up here. You're going over A, you're going down B, okay? So sine, for example, would be the y-coordinate, it'd be negative B. Cosine would be the x-coordinate, it would be A. So that's the sort of thing that's going on in the last problem on 7.3. It's not really super hard, but it's one of those questions if you don't exactly know what they're asking for, it's a little hard to get into. So hope that helps.